All right, so we know that the river is 2 meters per second like this. The boat has a maximum speed of 8 meters per second. And then the kid is 200 meters out, 1,500 meters upriver. Now, if we use the water as the frame of reference, okay, and then put the boat, and the boat is in the water, then with respect to the kid, the boat just goes straight out and picks the kid up. So that means the boat has to be pointing straight wherever the kid was at time 0. And we can find that angle by using theta is inverse tangent of 200 over 1,500. So the inverse tangent, which gives us 7.59 degrees. Okay, now that's what's going to happen in the water, but both the boat and the kid are moving. So what's going to happen is the water, the river current with respect to the dock, whatever, the dock, I don't know what a dock looks like, usually sticks out in the water or something like that. But with respect to, it looks like a big cross, but whatever. With respect to the dock, both the kid and the boat are changing. So the kid's velocity is 0 with respect to the water. So with respect to the land, it's 2 down. The boat's velocity is 8 meters per second at an angle, but it is 8 cos 7.59. It is 7.93 meters per second upstream, and it is 1.04 meters per second out across. So just like with the kid, we said the kid's velocity is 0 with respect to the water, but it is -2 with respect to the land. We have to do the same thing. The current of the river doesn't affect the horizontal velocity of the boat. It only affects the vertical velocity of the boat. So whatever, north, something like that. It's an aerial picture. But so we just subtract from here. So the Vx of the boat is 1.04 meters per second. That doesn't change. But the Vy of the boat is 5.93 meters per second. Because, or with respect, this is with respect to the dock. With respect to the water, it's these numbers here. But with respect to the dock, it's that number there. So then that says theta equals inverse tangent of 1.04 over 5.93. Maybe I shouldn't use theta. Let me use phi. And phi is the angle at which the boat is going to go with respect to the dock. So inverse tangent of 1.04 divided by 7.93. Oh, just kidding. Not 7.93, but in fact 5.93. And I get 9.95 degrees. So pretty close to 10 degrees. All right, so there's a difference of a couple of degrees because of the current in the river. And this should make sense, because what that means, if I'll draw this in yellow for you, and I'm going to exaggerate the angle, this angle is phi. And that makes sense, because the kid, after some amount of time, has gone downstream to this point. And the boat has to have an angle that will allow it to get there. So with respect to the shore, that angle will be 9.95 degrees. With respect to the kid, well, the shore originally, the boat just stays pointed at the 8 degrees. But if we were in a helicopter above watching what happens, the yellow line would be the trajectory of the boat. The dotted line would be the heading of the boat. Hope that makes sense.